All right, so again, I asked you, give me an example of a purchase. If airheads are $1, honey buns are $2. He walks in with 20. Naughty said, well, he could buy 10 airheads and you said 5 honey buns, right? So if we do the math, 5 honey buns is $10. Thank you. 10 airheads is also $10. So yeah, he could buy that. He's got $20. That works. Here's another one.
A charger
Charger.
Yeah, maybe still chargers.
Look, 18 airheads and 1 honey bun. 18 airheads, 1 honey bun. That would be $18 plus $2. Yep, that would be $20. That would work. Hey John, what do you keep saying?
I said 1 and 1.
Hey John said 1 and 1.
Sorry.
I got one.
He can make the purchase, can he? Exactly.
Right.
Exactly.
Yeah, you're right.
He's actually exactly right. Whole point of this lesson. Did I ever say anything about how much he had to spend?
Nope.
I said he has $20, so he can spend $20.
Smart, huh?
I never said he spent all $20 or he's going to spend all $20. So yeah, you could buy that. That only spent $3, but he could absolutely do that. That is a purchase he could make. So what we're moving into is this. We're graphing any, so again, still graphing. That's why we kept doing graphing, even though we had kind of moved on. The whole next 2 lessons are all graphing. You're still struggling with graphing, you're going to be in trouble because remember, we only have 3 weeks left. 2 of those 3 weeks are all graphing. Still struggling with graphing. I'm not sure what you're going to do to get your grade up. So you've got to learn graphing. I keep telling you that, but now you're down to crunch time where if you don't learn it, I mean, there's nothing I can do for you on your grade. The next 2 exit tickets are going to be pretty much all graphing. And there's a little more to it even than just the graphing, but if you can't do the first part of it, the graphing we've been doing, then you're definitely not going to get to the second part of it. So you got to learn how to do graphing. So if you need help on that still, you need to come talk to me, go to G2, do something. We got better on the exit. Oh, the exit tickets were pretty good, by the way. They're not in the system yet. I was very kind on the grading because it did have some mistakes in it where you had to change equations and do some stuff that I didn't mean for you to have to do. So I was pretty kind on it also, which helped. But they were still better. I mean, a lot of people did get better at the graphing, which was good. And then we did okay on the elimination stuff. Some people didn't completely get it, but for the most part, we at least were able to do the basic level 1, and then level 2 we were okay at, and then after that we struggled a little bit. But they'll be in, I don't know that I'll get them in, I'll try to get them in tonight. I have practice after school for flag football, so probably won't get them in before then. Oh, and I'm also taking requests for my next, did I tell you guys I'm not going to be teaching here very long?
Wait, what?
Most likely.
This
Did I tell you that? Well, I did my first TikTok video and it's blowing up.
Oh,
So
yeah, I saw
I'm pretty
that.
sure that I'm gonna
Yeah,
have all
you
kind of
see?
endorsement offers and movie deals and all kind of stuff.
Bro,
So,
that was
yeah.
funny. Them after
Odds are that I probably won't have to be teaching much longer. I'm gonna be pretty famous. So, So what we're moving into now? No, not right now. Not right now.
Yes,
Not right now. You'll have time. You'll have time left over to even be on phones as long as you just pay attention and participate. So, what we're moving into now, here's your topic. Graphing inequalities in 2 variables. It's just graphing, only there's one extra step we have to take because now the solution isn't just the left side equals the right side. The solution is actually going to include an inequality symbol. So if you remember an inequality we did before with only one variable, something like x can be less than 3. Well, 3 is not the only answer to that. Actually, 3 is not even an answer to that. There's every number less than 3 as an answer. So we couldn't just say, oh yeah, it's x equals this. We had to graph on a line. We drew a number line like this, 0, 1, 2, 3, and then -1, -2. We put a circle on the x. We said if x is not a solution, I'm sorry, if this number is not a solution, so where we put the circle, then we left the circle open. And then we shaded one direction. In this case, if it was less than 3, we would have shaded to the left, and we would show that that goes on forever. Every number to the left is a solution. So we did do inequalities, but there was only one variable. Now we're going to do inequalities, and we're going to have 2 variables. So we would create, that's probably not going to work. We would create an inequality from this. Kind of, we create the equation first, sort of, but really it's an inequality. Anybody have any idea how would we would create that? What do we know?
Yeah, you just right there. The honey bun and how much money he has to spend.
The amount of money he has to spend is still, I mean, it's really the same exact thing we did before. We're just going to put a different symbol instead of an equal sign. So we know he's spending 20. That's our number in this case. We're kind of putting at the end. It's the total. Still the total amount he could spend. So the total, we said, typically goes all by itself on one side of the equation. What is that money he's spending made up of? What is he potentially buying? Yeah, so it's going to be made up of $1 for Airheads, and then we would say $1 times what? Well, not times 2, because that's how much the other thing is. We wouldn't multiply the cost of each of them together.
Times of the amount
yeah, right. If you went in and bought a number of Airheads, you would say, well, they're $1 each. I bought 10 of them, or whatever number you bought, and you'd multiply those 2 together. So what would we write for the rest of it?
2 times what that amount.
Yeah, and then we would use a different variable because he's not going to buy probably the same amount of honey buns and Airheads. He could, and we could still have X and Y be the same number, but there's a lot of examples where they wouldn't be the same number. Like one of them could be 20 and 0. One of them we said could be 10 and 5. So the X's and Y's are going to most of the time be different. They might wind up being the same in some equations. So then what would we put here though? That's the difference that we're getting to when we create the equation. We don't put an equal sign because we didn't say he spent 20. So what symbol has to go there? What was the symbols we learned? For inequalities. Well, what's that called?
The arrow.
Jasmine's giving me a peace sign.
Gator.
Yeah, what is it called?
Oh.
Remember, Gator eats the bigger number, that whole thing. What was the symbol called that we need?
Greater than. Less than.
That's one of them. So which one do we need? Greater than or less than?
Greater than. Less, because you're spending the
We
money.
need to be less than 20, right? This is how much I spend. I can't spend more than 20. So is that good? We done?
No.
Everybody good with that?
No, we're not
Why are we
done.
not done?
Less than.
I could spend exactly, right? In this case, it's saying I have to spend less than 20. That would be the rule. But I don't have to spend less than. I could spend exactly 20 because we said right here, that's exactly 20. That's exactly 20. So that's what the new inequality would be. Instead of an equal sign, you've got to figure out, and sometimes you may still have an equal sign, sometimes you may not. You've got to figure out what symbol goes there. This part was the exact same. All of this stuff, that stuff over there, that was the exact same way we did it when we've done word problems before. Eventually, there will be a quiz that has quite a few word problems on it, but not probably this quarter, probably next quarter. Any questions on anything I created there? The real lesson today is we're doing how to graph this, which is pretty similar to what we've done before, but we have to add a couple little pieces in. No questions? Go fast, because you need to, this next part is the actual lesson today. That was more of a reminder, sort of, and just an introduction to going back into inequalities. All right, so, come grab one of these. Come grab a sheet of graph paper. Yeah, plenty, should be plenty of them. We'll probably only use a couple of them. If you have one already that has a couple blank graphs, you can use that. I gave a bunch of them out in the past, I know. Really good. All right, so what kind of, and again, when we graphed before, we had a yellow sheet and a white sheet. We use those same sheets. It's still going to be either Y-intercept and then rise and run, or it's going to be plug in 0 for X, solve for Y, plug in 0 for Y, solve for X. That's still the first step. And then after that, though, we've got to change something a little bit. There's one more thing we have to add on that we didn't have to do before when it was an equal sign. You don't have to graph this first one because your graphs actually don't even go up this high. So just kind of follow along. Again, this should be pretty much a review of how to graph. So there's our inequality. It's still the same concept for the creating the line part. We are going to create a line first. That's not the end of it in this type of graphing like it was before, but we still need the line first. So ultimately, I just need values because a line is all the points that make the left side. Oh, write this down. Even in an inequality. So just because we're doing inequalities, this part doesn't change. So even in an inequality, or also for inequalities, or however you want to write it. And I'll let you write that down. I'm sure I'll have to repeat it at least once more if you didn't get all of that. So again, even for an inequality. Once you're done, you kind of look up, so I know you've got all of that. We're done. Good, Kira. So the points on the line still make the left side equal the right side. That's always true. Whenever you graph a line, even if it's an inequality instead of an equation, the points on the line make the left side equal the right side. So whatever points we came up with that equaled 20, that would make the left side equal the right side. We can use those same points to create our line. So what were some of the ones we said? Do you remember? 1, well, 1 and 1 doesn't make the left side equal the right side. I'm talking about the ones that made the first few that we got before we came to yours. Somebody said 18 and 2, I'm pretty sure. So, oh, by the way, I'm counting by twos. So if that's confusing, I'll write them in at least up here because I only have 10 lines, so I can't count by ones. So just remember that as I'm graphing, this is actually 20 all the way out here, 18. I'm not going to write them all on the bottom, but it goes by twos on the bottom also. So we said I could buy 20 honey buns, right? And then 20 airheads and 0 honey buns. So I could buy that right there. That's $20 even. That would make the left side equal the right side. What else would be exactly $20 we said? We said 18 and 1, right? 18 airheads is $18. 1 honey bun is $2. So that would work. What else? We said at least one more. 5 of what and what? 10 of which one? 10 airheads, right? So 2, 4, 6, 8, 10, 2, 4, and then 5 right there. So that would work. What else? A whole bunch of them. At least give me one more that I'm thinking of. Yeah, we could just buy all honey buns, right? 10 honey buns is $20. We're graphing now. Oh, if you don't have a graph sheet, grab a graph sheet. So you should kind of notice something about those points. Even though some of them are a little farther away, do you notice anything about those points? I'll give you a hint. Big hint. Now do you notice anything about the points? Ta-da. Now do you notice anything about those points? They line up, right? They were following a pattern. So every point that we just came up with equaled 20. We had $20. But also any point on that line. So we could just pick a point on the line now and say, okay, well, if I just wanted to know a possible purchase that would equal exactly 20, 2, 4, 6, 8, 2, 4, 6. So 8 airheads, 6 honey buns. Boom. I can just look at the line now and come up with all the possible ones. Anything that falls on that line is a possible purchase. But that only takes care of where we equal 20. What did you give me, Tejan? What did you give me? What did you say goodbye?
What I said?
Yeah.
That's 1 1. That's what I said.
So Tejan said, yeah, but wait a minute. It never said in there that it had to equal 20. He could walk in and decide he only wants 1 of each. And he's absolutely right. He could walk in and decide he has absolutely 1 of each. So he said he could buy 1 and 1 right here. Somewhere right there. That works, right? He buys $2 or spends $2 on a honey bun, $1 on an airhead. That's $3. He could absolutely buy that. What else could he buy? Give me another one he could buy.
Like 5.
There she is. What else? You got some catching up to do now, but that's the beginning of it. So we're graphing inequality. So that's your topic there. You can write that down and get caught up with us. What else do you buy? Brooklyn, what else do you buy? Because we said he doesn't have to spend 20, so what else could he buy?
4 airheads, 2 honey buns.
Sure, absolutely he could buy 4. So he could buy 4 airheads, 2 honey buns. That would be a total of $6. He's got 20, of course he can buy that. We never said he had to spend 20 in this. That's why it's less than or equal to 20. Give me another one.
5.
You could buy 5 and 5, right? You could buy 5 airheads, 5 honey buns, would be somewhere in the middle there. That would be how much money? Somebody's quick with math. 5 times 2 would be the 10, plus another 5 for the airheads would be 15. So that's under $20. How about this? Give me something he can't buy. What's a combination he couldn't buy? He doesn't have that much money.
0, 0.
Well, no, he could buy 0, 0. Actually, that's one he can't buy. He could say, you know what? I didn't know last week they didn't cost this much. Last week they were only 75 cents and $1.50. I'm not spending $1 and $2. So he could walk out and not buy anything. So that's actually one he can buy, 0, 0.
10.
So,
He can't buy 11 airheads and 5 honey buns.
okay, so he can't buy 11 airheads. So I'm going to go to blue. So 4, 6, 8, 10, 11. And you said 11 and 5, right? Is that what you said?
11 and 5.
Yep.
So he can't buy that, because let's do the math. So 11 airheads is $11. 5 honey buns is 10, so that's $21. So $1 over. He can't buy it. Did you have one you were going to say? Or? Shut up. No way.
10.
What else?
10 more.
10 what?
10.
Depend. 10 honey buns would be 20, right? And then 1 airhead would be 21. So 10 honey buns, though, is up here. 1 airhead is right there. What else? 7 and 7. You guys are funny. So 7 and 7. 6, 7, and 7 would be right there. What else?
7, 11.
How about like 20 and 20? Like just pick big numbers. Something you know he can't do. He can't buy 20 and 20, right? There's no way. He's not even close.
7, 11.
How much money is 20 and 20?
60.
60 actually, right? Because 20 times 2 would be 40, plus 20 for the airheads would be 60. We'll come back to what I was about to say. Give me one more. 7 airheads, 11 honey buns. So that would be 6, 7, 11. You guys are picking a lot of odd numbers. So yeah, 7 times, which one was it? Airheads?
Oh, well, 7-Eleven.
7 airheads. It was right there, right? So 7 airheads is $7 plus 22 is 29. So yeah, can't buy that. So here, I'll give any of you an A right now in this class for the quarter. If you can give me this, either of these. Give me a point that is above the line that he could buy. Any point above the line that he could buy, he'd be able to buy that amount.
17 airheads. We. Wait, what was the question?
Say Damani just woke up and I said I'll give you an A.
17 airheads and 2 ones.
So first of all, let's make sure it's above. So 17 would be here. Up, it's above. It is above the line, but it wouldn't work. So 16 and 2 is on the line. It's got to be above the line.
Where's 17 and 1?
Well, 17 airheads and 1 is $19. So he,
You guys spent all of it?
well, I'm sorry, no. But that's not above the line. 17 is here. 1 is just below the line. 17 and 2 won't work though. That'd be 21.
17 and a half.
Not possible. Although we
14
could
and
actually
4.
still test that. If you could buy a half a honey bun, we could still test that.
Guarantee you can.
Because we could even test negative numbers too. I'll just go ahead and let you know.
Okay, let me check. 14 and yeah, 14 and 4.
So 14 and 4. Let's make sure it's above. So 18, 16, 14 and 4 is above, right?
Mhm.
So 14 plus 8, 22. I can't buy it.
Bro, what?
It's too old. Come on. Give me at least a B.
It's impossible. Absolutely. Why do you think I said I'd give you an A? You can't do it. And here's why. Once you've graphed the line in an inequality, this is all of the points that are on the line, meaning they make the left side equal the right side. This is the dividing line right here. Anything above that doesn't work. Everything below it does work. No exceptions. It's like the border. It's the dividing line. Once you cross it, you go into the other land, the land that doesn't work. Or if you're on the side where it doesn't work and you cross it, you go into the land that does work. There is no exception to that. So write a note. On the side where you have a so we had solutions that work. Red worked. Everything that I put in red, all those work. Everything on that side will work. You pick any point below that line, guarantee you it works. You can pick negatives, I don't care. If it's below that line, every single point below that line works.
Wait, can you say that?
Yep. Well, let me say, I'm going to say the whole thing in a second. For the blue were points that did not work. Again, every single point above the line will not work. Guaranteed. There's no exceptions. Because the line is like the dividing line. Like I said, once you cross over the line, you go into the opposite land, either the land that works or the land that doesn't work. That's why the points on the line equal the left and the right, because that's right in the middle of the ones that work and don't work. So any point above the line, the left side will be greater than the right side, so it wouldn't work. Anything, and that's, you know, a clear one to say is 12. If we pick 20. Oh, and the farther away from the line you are, by the way, the farther away you are from the $20. Like you notice when I picked this point way up here, that was $60. But when we put all these points right next to the line, those were $21. So the farther away from the line you get, the farther away you get from like actually making the equation true, the inequality true. Now, if we pick points on the red, again, the closer we are to the line, the closer we are to $20. 0 was, you know, $0, so we're way away from $20 if we're at $0. So it's kind of the same thing. The farther away from the line you get, the farther away from the 20 you get. And that's why the line is the middle. I mean, it's really the middle because it makes the left side equal the right side. But one side, every solution works. And this is one side of the line. The other side of the line, no solution works. You've got to get and then on the line, the left side equals the right side. So those are the three things you've got to understand from today. We're going to graph some also, which, you know, we got to be able to graph. But as far as a concept goes, there's three things. The line itself makes the left side equal the right side. Then one side of the line, every solution will work. The other side of the line, no solution will work. So here's how we show the side of the line where every solution works. Because again, we want to be able to say where our answers are, right? I mean, that's typically we gotta answer the question. If they say where's your answer at? Well, there's not just one answer. We can't just write one combination because there's all kind of combinations. We can't just graph a line because the line isn't all the answers because we could be less than 20 in this case. So we draw a line and then you have to shade in the side that is the solution side. So we would shade in this case the below the line because that's all the points we said that worked. So again, any you say we're saying audio. So here's what you can write. Let's say I already give you a graph and it's done for you. And let's say I don't even give you an equation. Maybe I just give you the graph of the line in the shaded area. So here's your next note. Every point in the shaded area is an answer. It is a solution to your inequality. Every point, and again, this is a huge, easy thing you need to know because they guarantee you there's going to be one or two questions that are what I consider to be very easy questions on there, and this is that type of question. You need to understand every point in the shaded area. If I give you something already graphed, every point in that shaded area is a solution to your inequality. Even if I don't give you an equation, like an inequality. Like let's say I didn't give you this, but I gave you just that graph. No inequality with numbers and variables. You should be able to tell me, yeah, I know all the points in this shaded area work because that's how we represent the answer is by shading it. So every point in the shaded area is an answer, is a solution. Let me ask you this. Are the points on the line a solution? Do the points on the line work? Why do you say no? Which is funny because you weren't even in here when we went over it, but I appreciate you throwing it out there.
No. It's not in the shaded part.
So it's not really in the shaded part. So we treat the lines separate from the shaded part. So what did we say the points on the line do or are, or like what's true about the points on the line? This is always, whenever you graph a line. Points on the line, what? What do we say? Just said it a little while ago. You weren't in here. I mean, you've been in here before. We said it before. Points on the line, what? This is one of the things I said you had to know. One of the three things I just said a minute ago. Apparently we didn't write it down. Say it again. The points on the line make the left side equal the right side. I don't care what the symbols are. I don't care what symbol is here. It could be greater than, it could be less than, it could be equal to, it could be greater than or less than. It could be greater than or equal to. Less than or equal to, I mean. Can't be greater than or less than. The points on the line will always make the left side equal the right side. Always. So here's what you have to do. You have to say, okay, well, if the points on the line make the left side equal the right side, is that making this a true statement? So for example, if we buy 18 airheads and 1 honey bun, which is on the line, is that a solution? Like, can we do that? Does that make the left side, or does that make the statement a true statement? What is our statement in this one? Like, just read what it says. Hey John, what's it say?
What?
The statement. What does that read? How we would say that out loud? And you could just say left side and right side. You don't even have to say the 1x 2y. Left side has to be what?
What?
Read this statement. This is the rule. This is the rule. The left side has to be what?
Left, right?
Well, not equal. There's two symbols in there, really.
Equal. What greater than?
It has to less than. The left side has to be less than or equal to 20. Well, if every point on the line is equal to 20, then yeah, those points work. Every point on the line will make the left side equal the right side, so they will work for this inequality. Here's your next note, and you can write this however you want. What if I did this? What if I said this is the equation? Now, a solution has to be less than 20. Has to be less than. Can't be equal to anymore to be a solution. Now the points on the line work.
No.
They don't work because all the points on the line make the left side equal 20. We just said that. Every point on that line makes the left side equal the right side. That's always the case. But our rule now is we have to be less than 20. We can't equal 20 anymore if I change it to that new inequality. So now the points on the line don't work. So here's your next note. Sometimes the points on the line work, sometimes they don't. And we're going to go into more detail about how to figure that out. So you may want to leave some blank space under that. Leave some blank space to fill that in next class. We're going to give more to that. If they don't work, let me just show you one thing. Yeah, I can do this. If they don't work, the way that we show they don't work is we have to change the way the line looks. It's kind of like when we graphed, we had an open circle, or sometimes we shaded the circle in when we did the graphing on just one number line. This is the same concept. If they work, like they did before I changed it, we make it a solid line. If they don't work, which now they don't work, this point now, 10 and 0, well, 10 honey buns is 20, but if we need to be less than 20, 20 is not less than 20. So if we plugged in 10 for Y, the left side would be 20, but that doesn't work anymore because we took away the little equal sign guy. So the points on the line no longer work. The points on the line are going to equal 20, not be less than 20. The only points less than 20 are all the shaded points. Those will all come out to be less than 20. And that will be simpler on Wednesday, so don't freak out if you're not getting that part. The main thing is, again, you need to understand shaded region, all of our possible solutions. The other side, no solutions. If it's not shaded, then there's no solutions. The line itself, sometimes they work, sometimes they don't, depending on what your symbol is in the middle. But they always make the left side equal the right side. Every point on that line will always make the left side equal the right side. That's always true. It's just they may or may not be a solution depending on what our inequality is. So what I want to do, yeah, we got time. One problem real quick. I want you to graph something just to practice graphing. Uh-oh.
It's okay, I just need some more for students to finish up.
Some work? Is that what you said?
Yes. Take some more with me too.
Who? Because it depends on what class they're in. I have two classes.
1A.
Oh, 1A. Don't know what they're going to be able to do.
Henderson.
I mean, this is pretty old, but we're getting back into graphing. So I would say that he has not probably learned how to do that yet. So if he can get through that, I'll bring you something else. But
Is there any book or anything that he can look through? Do you have a book?
Yeah, but they don't tell you how to do a whole lot. They're the books behind you. They're more workbooks, not book books. So.
All right.
Yeah.
Nothing else. Okay.
I mean, they have some sheets, but I don't have any probably extra sheets for him.
Okay.
So, like, I mean, basically it's, well, I got recorded videos if you want to let him use his phone. I record all the lessons, so they're lessons.
There is a laptop in there.
Oh, yeah, then he can go to my YouTube and watch on graphing.
Okay.
Yeah,
Gotcha.
that's their main resource normally. All right, so again, everything in the shaded area is a solution. Everything not shaded, not a solution, will not work. On the line, it depends. Might work, might not work. It depends on what your symbol is here. But regardless of what your symbol is, those points on the line always make the left side equal the right side. So here's what I want you to graph. Let's just practice doing one with the Y. Oh, I don't know what I'm doing there. Is anybody using this? I'm about to get rid of it. Get rid of that. Get rid of that. So here's what I want you to graph. I mean, we're going to sort of do it together, but I want you to start it on your own. So this is Y all by itself. How do we graph when Y is all by itself? What do? There's two methods for graphing. One is using the Y-intercept and rise over run. One is plugging in 0 for X, solving for Y, then plugging in 0 for Y, solving for X. Which method do we use here? This is a rise, run, Y-intercept, correct. So you need to take your Y-intercept, so write this equation over one of your graphs, and then start by putting a point on your Y-intercept. That goes on the Y-axis, not the X. I still had some people on the exit ticket putting it on the X-axis. Some people were putting the wrong number on the Y-intercept because they were using the number that should have been the slope. They were reversing them, although not many people did that. Some people did put X, by the way, for the slope in that one section where I just said, tell me the slope of the Y-intercept. Every time you did that, it was wrong. So if you did it for every one, you missed every single one of them. So that hurts some people. Because I don't know how many times I've said X is not part of the slope. It's not. I'm going to zoom in even more. Oh, maybe I can't. Oh, yeah, I can. There we go. So you should have the, if you don't have the equation written down, it was Y equals 2X plus 1. Oh, shoot. I think I messed it up. Yeah, it should be this. So fix it. If you need to rewrite it, just rewrite it. Because we're doing inequalities now, so I can't put an equal sign there. Now we still graph it as if there was an equal sign there. So we still do that, but then we just have to do something else. So again, Y is less than 2X plus 1. Or were you trying to do one? That's why. What's your first graph? Did you start over again? Or did you scratch it all out?
No.
Oh, that's your shape. Oh, so you did. How did you get the 20? Because that one went for 20. Like shiving was 20 here. You just kind of. Not a lot of graphs going on. Draw the line all the way. This is why I told you need to get used to drawing the line all the way across the graph. Because now that we're into this shading lesson, the inequality lesson, you've got to have a line that goes all the way across the graph so that when you shade it, you know which side to shade. And so that it's clear to me that you understand all of the components of the graph. If you're just putting 2 points in a really short line, that's not going to work in this lesson. Boy, oh boy, we are struggling with graphing still.
Did I do it? I have to line through it.
Oh, I can't. If I didn't see a line, then I didn't check it. I assumed you hadn't done anything. So draw a dark line if you want me to look at it. Well, remember, it's a pattern of over 1, up 2, over 1, up 2. If you want to just do a bunch more dots, and that'll help you put a straighter line.
That's right?
I think it looks good. I didn't count it.
It's just 1, 2.
No. So like I said, your next 2 lessons are graphing. I don't know how you're going to pass this quarter if you're already in trouble and you don't know how to graph. I mean, I'm gonna tell you.
We're not going to move on from that.
We did move away from it, and then we came back to it. The only reason you had graphing on the last two is because I knew it was coming up in this lesson, so I didn't want to completely move away from it. Can't see where the y-intercept is, but assuming it's on the right number, then that was. All right, so I'm gonna go ahead and do it, but I mean, you guys have got to get some help on this if you're struggling. Like the entire next exit ticket. Maybe there'll be 10 points on something else. Maybe not. It might all be on graphing. When there might be some questions on there, you might not have to sit there and graph, but it's all about graphing. I mean, that's this topic, graphing inequalities. So my first point goes on the y-intercept. That's the y-intercept, +1. A lot of us still struggled when there was a negative sign in front of that. You've got to include whatever sign is in front of the number, and then you put a point on that, so +1. From there, the slope is 2. We make that a fraction. We write next to that rise over run. Then you can just follow, I erased that word. You can just follow the directions. So we go over 1, up 2. That would be my second point. You can keep going over 1, up 2 to make it straighter. Now you draw your line. The points on, pay attention. You can pack up in a minute, pay attention. The points on the line are not an answer. The points on the line would make this side equal that side. Well, we don't have the little or equal to thing. We don't want it to be equal. We want it to be less than. So we would have to fix it by making it dashed. So we would make it dashed like that, showing that those points don't work on the line. And then we have to shade. When you shade, you just got to figure out which side works, which side doesn't. Well, if I need y to be less than the right side, I can probably pick a point that's down here and it would work. 1 times 2 plus 1 would be 3, and the y would be 3, so 1 and 3 would be on the line, 1 and 2 would be below the line, so that would work. We'll do more of that next class. The main thing is getting the line there today. So like I said, you're struggling on how to get that line in there still. You need to go to G2 or you need to see me. Tutoring, that's the tutoring room. Every day at lunch, they're in their both lunches and they're after school for an hour. So even if you just go in at lunch for 15 or 20 minutes and just say, I need to know how to graph this type of an equation, you can do that in 15 or 20 minutes, especially if you do it a couple of times. We'll get to the shading part when we have a more full day on Wednesday. I'm sorry, tomorrow for you guys. And if you have the next TikTok you want me to do, you gotta let me know.
Hey, do the gritty real quick.
I don't know any of them. I'm taking requests.
You killed it though. You was
I've never heard of
really
it. I have no idea what they got.
You drank what? I showed him how to get started.